Good afternoon. I welcome you all for next class. So in this class, we are going to discuss about addressing modes of ARM. So I think for the last class, we have discussed ARM processor architecture. So architecture means it consists of some blocks, how the data are transferred between the blocks. So that we are discussing in the last class. So this is a recap of session. So anyone can say what is addressing mode. I think we are discussed in 86 and 51. 80, 51 we are already we are discussed related to the this topic, that is addressing mode. Anyone can say what is addressing mode or define addressing mode? Yes, addressing modes are how the CPU locate the apparent location. That's called as the addressing mode. So based on the location, the data transfer or move or shift the data to the based on the operand. So here we are going to see four type of addressing modes, which is listed in ARM processor. So one is the register addressing mode, and the indirect addressing mode for relative registers, and indirect addressing method with the base index. And fourth one is scale in register addressing mode. So you have to see one by one with the example. So first one is register indirect addressing mode. So the name itself, it consists, we are transferring the data indirectly register to register. That's why it's called as the register indirect addressing mode. See the example, LDR R0 comma within square bracket, it consists of R1 is an example. Actually, what will happen? The register R1 consists of some word at the memory location, and the word is transferred to R0. We can say it is moved or load to the R0. And indirect register relative registers, and it consists of two type of addressing. One is pre-indexed and post-indexed. So can say the example for the pre-index, we can take it out, consider as the LDR R0 R1 comma hash 4. So first the R0 consists of some local value that is transferred to R0, and the R0 value is added with the 4, the constant value 4 is added with R0, and it is stored into the R1. And this is the diagram for pre-indexing mode. So here they are mentioning some address, that is it consists of 4 and added with 4, and it is um, created the next memory location, that is it consists of 4, that is 4 plus 4 8. So this is the example for pre-indexed mode. And this is for post-indexed. So post-indexed, we are considering the same type of instructions, so which consist of the symbol like this. So what will happen? First, the instruction R1 moved to the R0 register. So what are all the information it consists in R1? That word is, that 32 word is transferred to R0. After that, the computer, it created the new address, that is multiplied by R1 by 4. So R1, what are the information consist? Or a location, it is multiplied by 4, and it will be stored into the R1, which is considered as the new address. This is called as the post-indexed addressing. And the next addressing mode is the indirect addressing method with the base index. So the memory address is produced adding, that is for example, we are taken as for the related base index, LDR R0, R1, R2. So what will happen? So adding of the content in the registers R1 and R2, the same information loaded into R0. And for the pre-indexed addressing, so first the R0 consists some data is transferred to or loaded into R0. After that, it will be created the new address, that is the value of R1 and R2 are added, and the result will be stored into the R1. and this considered as the new addressing. And then finally, the scaled register addressing mode as a base. So in this base, we are that is what will happen. The addressing mode memory address is produced by the adding of registers value to another register that is moved left in this addressing scheme. So for this, we are taking the example, which consists of R1 and R2, adding of these two values, and it is shifted in left by 2 position, and the result will be stored into the R0. And this is how the scaled register addressing mode are working. So I think today we are discussed about addressing mode. So if you all have any doubt, please ask. Thank you all.